Howdy, folks. Craig Lavati here at the Houston Museum of Natural Science and the HMNS Beyond Bones podcast. You can now check us out on all of your favorite podcast apps. And also, let's just give a moment of silence for this microphone that valiantly lost its life today when I accidentally dropped it. So many good shows.
Howdy, folks. Craig Lavati here at the Houston Museum of Natural Science. And it's a sad day, folks. My microphone broke just before we went to record the show. I had to jump up out of my desk really quick because I thought my little old dog was about to christen the new carpet, and this thing broke. Guys, we have some really cool news before we get to our guest. If you watch us on YouTube, thank you. That's awesome. But we know that a lot of people would like to listen to us, while they're running errands, while they're at the grocery store trying to shut out, human contact. You can now listen to us on your various podcast platforms that you love. Search HMNS Beyond Bones podcast. You have to search that to get the current run of shows, this version of shows. Check out Spotify, Audible, Google Podcasts, Spreaker, and coming soon to Apple. So you will be able to listen to us while you are at work or whatever else you do when you're listening to podcasts. I don't know. It's not my that's not my business. It's not me and Kat's business. You do what you need to do. Kat, how are you doing?
I'm doing great. I'm doing real good. How about yourself?
You are very colorful today. I'm great, but you're very colorful today. Yes.
Thank you.
There you go. Today's show is really cool. I bought my $10 Walmart NASA hat on. We're talking to our VP of Astronomy at HMNS, Dr. Carolyn Sumners.
Hey, Carolyn.
It's a good year for astronomy.
Yes, it is. It's the kind of year you were made for.
I hope so.
So today we wanted to talk about the current, what do you want to call it? It's probably the biggest astronomy news in some time, the biggest telescope news, the James Webb Space Telescope. And Carolyn, you've been excited about this thing for a long time.
Oh, it's huge. It's different from Hubble.
It's literally huge.
It's literally huge. It's always good.
Yeah.
It launched on Christmas Day. That's always wonderful. And it is working. And one thing about Hubble Space Telescope is in Earth orbit. So they screw it up and send up a craft and fix it.
Yeah.
And it can't screw up. It has to work right.
It's a million miles away.
Yes, it's at the Lagrangian 2 point, the L2 point. It's stable. A lot of craft are hanging around that area. And that's because the gravity of the sun and the earth are balanced there. It's right beyond the earth. And the earth is somewhat shields it from the sun. It has a big, huge tennis court size shield because this guy is not. Hubble looked at ultraviolet light and down a little bit into the microwaves and looked invisible. That was its goal. And it created gorgeous pictures. We can't ask for more.
Yeah.
But it told us there's more if you could just get further down. And so this is an infrared telescope. It does a little bit of maybe red and yellow, but that's it. It does infrared. Now, why do we care? Because the universe is redshifted. You may have heard about this, the idea that things that are far away, the Doppler shift works and the spectrum is shifted. So the light that was created in ultraviolet appears in our telescopes as infrared. It shifts toward the red. It's called redshift. And so this telescope will see things a lot further away, and red moves through dust. So it'll see things hidden behind dust. So it's going to see a lot more, but every Hubble image said, I could just see it in infrared. And that's what we're going to be doing. So I think most spectacular is the wavelength shift of the telescope. And the other is that it's a bigger telescope. It's 6.5 times bigger, 15 times more light gathering area. It's going to see better anyway, but it's going to see different, and that makes
I've always heard that the thing
with the successor.
I've always heard the thing with the Hubble was that it was sort of like looking at the universe through like a piece of wax paper, because it's so close to the Earth and you're still dealing with so many different variations and
it's not so bad in visible light, but when you get to infrared, the Earth is just hot.
Yeah. It disturbs the picture.
We're warm, so you have the telescope has to be at absolute zero as close as we can get it.
So I have a question about the mirror, Carolyn, because you were talking about there's going to be infrared pictures, right? So there's a gold mirror. It's fairly large and it absorbs certain wavelengths of light.
But it reflects infrared.
Oh, it reflects infrared. Okay, so it's not absorbing certain colors. What's the?
I won't absorb it. I want to reflect it.
It's a mirror. It's a mirror. Of course, it reflects it. But what's it?
Not the mirror, it's silver, and that's reflecting visible light.
Okay.
Gold is toward the infrared already, and we look at
it. Okay. So the purpose of that is
to look rich.
Great. I think that's a great purpose. It's a good answer. Good answer.
To make Congress happy with the money they spend.
Look at this. It's all bling. It's a bling telescope.
That's right.
So it launched out on Christmas Day. Obviously, that was a really cool Christmas present for people like us that are in the science world. It was great to see that. And then it's finally unfurled everything and it's tip top. Right now, it is currently January 19th, 2022. When will we be seeing the very first photos from the Webb?
That's a hard answer to give. It's got to cool down, and that's what takes forever and ever and ever. And the summer, for certain, we will have really quality, so they say, really quality IR images. Before that, I bet there'll be some test stuff that will come through just to see how things look. What you don't want to do is show an image that isn't really all that good, but proves you can make an image when everybody goes, that's not very good.
It loses interest.
When the telescope is cooled off, and you can't make it cool off any faster. So you hang on till it cools off until it really can do a good infrared image, and then you show it.
Is it hot from the traveling that far from the? What's it hot?
It's hot because the medium is warm. The sun warms it up until it gets the heat shield over.
Oh, deployed.
We're not talking about, a cold day in Houston. We're talking about close to absolute zero.
Okay. And like you said, it's 1 million miles away, and that's like at this perfect spot, basically, to where it gets far away enough from the sun and the Earth, as you said, to where it's just in a sweet spot for it to observe.
It's a stable point.
Okay.
And what you don't want to do is be firing your engines all the time. And you want to keep it so that it can aim toward Earth and it doesn't move relative to Earth. And that's why you pick these Lagrangian points. And we'll find in like the orbit of Jupiter, we find Lagrangian points where there are some asteroids hiding. Stuff gets stuck in Lagrangian points. They're not totally stable. The telescope's got to do some adjusting, but not much.
Is it possible that it could be damaged out there? If we're not, what's the deal with that? Is it, are we just kind of like on a wing and a prayer, hoping that, space debris doesn't completely, knock it out, use it as target practice? Well,
space debris is a bigger problem for the Hubble.
Okay.
Yeah, because that's closer to Earth. That's in Earth's orbit.
We have a lot of, think about how much stuff we have.
Micrometeorites would be
every day. Oh, and satellites floating around, and people blowing up. Like when the Chinese blew up a satellite several years ago in Earth orbit, we all went, the material from that satellite's still floating around, and that you just got to bring everything back you launch, and that no one does that. So
I've got a point to bring up.
It's out in interstellar space, interplanetary space, so we don't have nearly the noise, nearly the junk that could hit.
Right.
So producer Johnny here, I've got a quick question. We touched on it. Y'all touched on it. I've just been sitting back here eating lobster bisque. But y'all touched on
lobster.
It's actually crawfish bisques. I'm sorry.
Baby lobsters.
Little baby lobsters.
Yeah, I'm in Cape Cod right now. No. So he touched on it earlier with Hubble. And you mentioned, Carolyn, that you don't want the first images from the James Webb to come back kind of crappy so that the public, you don't want to publish those too much, because what happened with the Hubble was that the mirrors were out of line when they first launched, and the whole world, especially the US government, was like, what the heck did we just spend these millions and billions of dollars on? So can you kind of speak to how critical it is that the Hubble is close? They sent out astronauts in like 1990 to fix it, or 1991 to fix it. If the James Webb isn't perfect, if it ain't the perfect shot the first time, what can we even theoretically do about it?
Nothing.
Yeah, it's exciting. I was thinking that too. I was like, God, I hope they got this right, because I remember the Hubble didn't it just not deploy?
We can measure the reflectivity of the tennis court. We can. I mean, there's always something you can collect, but they're used to 8K. People want a lot of pixel images, and you don't get that unless you have a sharp telescope. However, infrared's a little more tolerant in some ways than visual, but the Hubble one is they use metric and English units because their problem.
Okay.
You remember, and they had to.
I do.
And they put glasses on it, and then they replaced the parts. So it's.
And I can understand too, like wanting to get those perfect pictures out there right off the bat, because I hate saying this, but with social media, like if you send back, a rough draft, people are going to go, why did we do that? And you want to bring back the most amazing picture possible that you can. Nobody wants to hear demo tapes. They want to see the original. They want to, they want the original thing. They want the most amazing picture.
And we've been working on this. They've been, this was supposed to launch like a decade ago, wasn't it, Carolyn?
Yes. Or more. Not quite that much, but it seems like it. And it is, when something is good, it comes and goes in the media. When
Right.
bad, it can linger forever.
Exactly.
And if it's been corrected, nobody notices.
Nobody cares.
Yeah.
You had your chance.
Yeah.
We're done with you now.
That's right. That's right.
What are the pictures going to look like? Do you have an example of what it might look like? You always have lots of examples and pictures and things.
Well, I wasn't anticipating that. But
I like to put you on the spot, Carolyn, because you're clever and like to keep you on your toes.
The Spitzer telescope is an infrared observatory.
Okay.
So you can happily Google it, and you will see that it's nice to contrast the two. In fact, they've made pictures of the Crab Nebula in all different wavelengths. And it's amazing how different wavelengths produce different colors. Now, that happens with us, too. I mean, if you think about you wearing these night goggles that are seeing infrared, and you can see people as shadows. So it looks very different, but you see things your visible light can't see. So this is the same principle, except there's more interesting things hiding about in the universe, because the universe emits all kind of colors of light, all kind of spectrum. Some things can only be seen in ultraviolet or in radio waves, which is way down the spectrum. So you will see something. And when you combine them, if you combine them cleverly enough, you can get some very pretty stuff. And you have to, when you see infrared images, you've got to read the caption, because we've false colored this color.
Yeah.
And this.
Right.
So it's not what the human eye would see. It's an interpretation of, because the human eye doesn't see infrared.
Right.
So infrared goggles. So it's got to be an interpretation of what we would see if
we
You taught me that years ago when we did a Facebook Live about the black hole photo. That that was all stitched together. Yeah, that was all stitched together from various observation points around the globe. That we got that photo. That was not just one camera pointing at it.
Right.
And the more data you have, the better the picture you have from different
and the more angles on it too. Yes.
Right.
Yeah.
Right. Okay, that makes sense.
So when it aims back at us, what will it see? Like that? What doors will it open on just our Earth if it aims back at Earth and we take a selfie with the James Webb? What will we see?
Do that. I don't think we'll have that as a priority, at least.
Okay.
It's an infrared telescope, and we're a lot brighter than the galaxies at the far end of things.
Yeah.
So I'm not sure you want to risk throwing that many photons into your telescope.
Okay.
Selfie.
That's just a question I'd seen. I was like, what are we going to? What will we observe? And what are some of the things that
and by the way, at L2, when you look toward us, you're also looking toward the sun.
Yeah.
I'd like to throw cosmic history out there because that's what we're going to be looking at. And I would like to know what in the world that means because it sounds real exciting. It really does.
The further away something is, the longer light has had to travel to get to you.
Mm-hmm.
So the sun is 8 minutes old when we see it. And that's kind of got it. That's where we're 8 light minutes from the sun.
And it's pretty close to us.
And it's awfully close. Mm-hmm. Now, if you want to see, we know the universe, we believe we know. And I would say this number's existed for 5 years. So it's probably truth that the universe is 13.8 billion years old. So things happened after the moment when the universe we can observe started that we can't see because it's been so redshifted and it's so far away. The object is so far away. And so that's what we're trying to do is to see those, we see teenage galaxies. We have a galaxy. We see teenage galaxies at the distance. We'd like to see baby galaxies.
And when you say that the universe is expanding, that's why it's far away.
The universe is expanding, and that's why, far away and expanding are actually have two effects. It's far away because it's far away, but the universe expands, that increases the distance between them, but also it redshifts the light.
Okay.
Doppler shift. When you hear a train coming towards you, the sound waves shift.
Okay.
Because you compress them and then you stretch them out. Well, light waves are the same.
Yeah. They behave the same.
Yeah.
Ish.
That's how we can tell when something's being orbited. Because if it wobbles, we can see we can see tiny Doppler shifts.
And that's the effect of gravity making it wobble.
Doesn't matter what makes it wobble. If it wobbles, if a light source wobbles, we will detect it because it will not maintain its colors, its spectral colors perfectly.
Okay.
Carolyn,
that's cool.
If it wobbles that way, it doesn't matter. It's got to wobble this way.
It's got to wobble the right way.
Yeah.
Carolyn, so here on Earth, a while back, they got an image of the supermassive black hole in M81. I believe it was M80. Was it M81? So my point is that we had.
That's okay.
We had
a galaxy.
Right. But the point is, what I'm trying to make is we had several telescopes based on Earth pointed at that galaxy to get an image of the black hole. Is the James Webb Space Telescope going to work in conjunction with other satellite telescopes to get us higher resolution of anything or see anything different?
I don't foresee that happening. But I mean, we've got a lot of time to play with it. I think the James Webb Telescope will be so prescribed as far as all the research, because we want to see baby galaxies. We want to see stars in formation. We want to see inside big molecular clouds and other clouds. We want to see the atmospheres, detect evidence of the atmospheres of planets going around other stars. And so all of these, and there's a lot of planets going around other stars we might look at. So there's so many things we want and the telescope doesn't just show a picture. The telescope collects data. It collects photons, and then it integrates a picture. So you may be dedicating a day of the telescope just to one picture or even longer.
And so we're using some kind of form of spectroscopy in order to do that, right? And I'm remembering summer camp with the tubes with the different types of gases inside of them being different colors of light. Is that the mechanism by which we're going to see what the planetary makeup is of distant exoplanets?
Yeah, we would like to know what's in those atmospheres. And if we can get any kind of spectral data that will help us tell that, because let's think about it. If a planet has an atmosphere of carbon dioxide, big whoop.
Right.
Carbon dioxide is very stable. Venus is full of it. Mars is full of it. No big deal. Doesn't say anything. It's fine to have carbon dioxide in your atmosphere, but it doesn't tell you anything. If you have oxygen in your atmosphere, it tells you something.
Yeah.
Oxygen oxidizes things and goes away.
Yeah.
Mars is red because its oxygen has gone into the surface. So oxygen has to be replenished. And therefore, if you can find oxygen in an atmosphere, you go, life makes oxygen.
Right. Let's go over there and build a Starbucks, that kind of thing.
Yeah, Starbucks. Priorities.
Let's go.
Well, so I guess another question would be, what's the best hope that we find out there? Like, do we have the government, as the government, like pretty much, are we worried about anything we'll see? Or are we going to be inspired by what we see?
Curious.
Yeah. Curious. Okay.
I don't think knowing where our galaxy came from and the Big Bang and that kind of stuff has any pragmatic value. I think it's curiosity. It's how atoms and molecules work. It's how things get started.
How it happened.
Timelines. It's a timeline, and we can make a better and better timeline. But I think the other question, the are we alone question, the question of planets having oxygen or whatever, is far more important, because the one thing science hates above all things is a sample of one. And when it comes to life, that's
repeatable. Yep.
No, we have one. We have one life form. You are 7% of your DNA is in a banana. We have one life form. And so what we don't, and even now, the new fun thing to think about is that life began on Mars, because Mars actually stabilized much more quickly than Earth. It had all the right conditions, and that the life that basically left Mars on meteorites that came to Earth, and life died on Mars because Mars dried up. Earth has not. Earth is dynamic, and life has evolved. Now, what's the sad thing there? There's still one life form. We don't want Mars life to have come from Earth, or Earth life to have come from Mars. We want a sample of two.
Right.
That will tell you right now, all we can say for sure is if you have exactly our DNA, exactly our environment, exactly our time frame, exactly everything we have, you will probably get life. But how much variability is
how
there?
much flex is there on either side, or different directions? Can you be silicone based, not carbon based? Can you be?
We haven't found, and the only definition for life is that it's reproducing and that it evolves. We added that to it, that it can't just reproduce because crystals reproduce. It has to actually evolve, to change as a reaction to its environment.
What do you after decades of your research and you teaching people and you shaping young minds and older minds like ours, if we do find out, if we peer out there and we find a planet that has oxygen in the atmosphere, and it is, I don't want to say just like us, but what do you think that would do? What does that do to mankind? Where do we go from there? Like, have you
watched sci-fi recently?
No, I live in that world.
We're gonna get a Stargate, Craig. We're gonna get a Stargate.
I'm just wondering, and this is positive. I don't mean this as a negative, but like, what would that do to the world at large? Like, would we kind of go, well, it's time to get out of here. Let's go over there, or what does that do to us? What do you see happening?
Over half the people we interviewed thought aliens were already here.
Yeah,
that was kind of exciting. I remember when Viking landed in the 1970s on Mars, this scientist who obviously had spent way too much time in a lab got a mic put in his face, and he said, well, he was hoped that humanity was ready if we happened to find life on Mars, that humanity could handle it. And all of us went, he's crazy.
Yeah. That would be exciting, just as long as it stays where it's at and we can stay here and just...
We don't even care about that. Most of the people I interviewed, of the hundreds I interviewed about Are We Alone, not only thought life was here, but were dying to shake hands with it. We're not a scared bunch.
I am.
Well, you're different. But anyway.
I'm more worried about them than us, if that makes any sense. Like, I'm worried about us tainting them, or us putting it off.
It depends on who visits who. Who visits whom. If they come here, they're going to destroy us. If we're going there, we'll probably destroy them.
Yeah, that's what I mean. So
they're going to come here to take our stuff. We've had this discussion. Why would you bother coming here if you didn't need something we had and you weren't willing to take it by force?
If you can get here, you don't need any of our stuff.
Yeah, that's probably true. That's a good point.
Yeah, you're not going like, ooh, cool. Like, you're not.
They have toast ovens.
I think you're going to be more of, but I don't trust humankind.
Well, you shouldn't.
Yeah,
that's actually a good policy.
And we brought that up on the show before. I don't trust us. Like, I think we'll go over there and we'll be like, oh, how do we bring guns here? How do we bring, what do we?
We may find out that life, when it becomes advanced, is actually self-destructive.
Yeah.
Ooh.
And if that's true, that by definition, advanced life also knows how to destroy itself and will.
Computers too. Advanced computers do that too. Self-destruct.
The computer, let the computer do it.
Yep.
So, and if that's the case, then then there's not going to be any other intelligent life out there because A, it has destroyed itself, and B, we've destroyed ourselves before we detect it. So,
because if we got that advanced to be able to detect it and find it, then we would already be destroyed.
Able to gun at each other and say bang.
So somehow it's not as depressing as you might think.
Well, no, I think what's important in all this is not to be depressed at all. Is that what if we are unique? If we are unique, then we are where we are. I mean, just because we exist doesn't make us not unique. That's why we need a sample of 2, because then we know we're not unique. Right now, we could be the only life that's ever managed to become advanced in the universe. There could be tons of planets where one thing went wrong, 10 things went wrong, everything went wrong. As far as we're concerned, what wrong is, and something that is sentient did not happen.
Maybe we are what went wrong with this planet.
I was about to say that.
Pretty negative.
Yeah,
I'm kidding. I was channeling Craig.
So that's what I'm saying. Like, what if we're the worst case scenario, and then there's some other world out there where they're like, I can't believe they only have like 2 arms and 2 legs. Wow, what a bunch of weirdos. I don't know. Like that's impossible.
That's somewhat justifiable that you have to have kind of location. How long you live, that's another question. But I don't think that we're nearly as negative as you all do.
I think that though, like 2 arms and 2 legs in the way, or 4 legs.
I mean that just like in general.
As an example, I'm just saying, we kind of evolved to suit whatever environment that we're in, and we're the best, probably fittest for that environment.
And we don't know how much environmental variation can exist.
Yeah.
I mean, getting a microbe may not be that hard.
Right.
Getting the microbe to evolve into a multicellular organism that can think.
You'd have to put pressure on it, right?
You got to stress it.
Mm-hmm.
You've got to have ice ages. You've got to have plate tectonics.
Mm-hmm.
You've got to have a big moon causing tides. You have to have a lot of things creating choke points to cause evolution.
Adaptations to those points and change over time. Listen to me. I'm throwing out all of the nomenclature across the science spectrum.
And I'm over here across town writing a Michael Bay movie. So I'm just like, like I'm writing a disaster movie.
Look at the poor dinosaurs. They got way too sophisticated.
Mm-hmm. They got uppity. That's what happened. They got uppity.
The asteroid did not hit them in the head.
No.
The asteroid changed their environment.
And they could not adapt fast enough. They were too big, probably.
Too big, too picky.
Mm-hmm.
Turtles. They say that if you look at the turtle history, turtles did hardly even notice the asteroid.
Well, they just went underwater further, stayed longer.
And they could eat anything. A lot of dead dinosaurs floating around.
Yeah, it was the end of the world for the dinosaurs, but not for the mammals that were scurrying underground that were like,
something
eating.
New takes its place.
Yeah.
Being able to eat carrion had a huge advantages.
That was a buffet at that point. There's
right.
Where do we
buzzards were the birds that made it the best.
How detailed? I know about the infrared thing, but how detailed can the James Webb get if it aims itself? And I know there's a lot of different projects and little. I know there's groups that have like stuff on the docket for the James Webb to do. Like, hey, for 2 months can you do this? For 2 months can you do that? How detailed can the James Webb get if it points itself at something? Like, are we saying surface, or are we just saying like it can just?
Hard question to answer.
Okay.
Because it's how big is the object. It's how much at that distance, at that size. What's its pixel density is much better than Hubble. I mean, it would give us a much 50. I had that number somewhere around here.
Because like the Hubble can look back at us.
Some people say 100. Yeah, but it's because Hubble can see Hubble's looking at visible light.
Yeah.
The James Webb wasn't put in space to give you a selfie, sweetie.
Okay. I want a selfie of the Earth. That's what I want. I want us to have spent $70 billion on a selfie of Earth and then unplug the thing and go back home. That's what I want. But I also want to see, further out there. Do you think this is the kind of stuff that will really, are we setting the table now for the next few thousand years of space exploration just by the Webb getting out there?
No. The Webb is increasing our knowledge base. It's giving us neater images. It's giving us some idea of the variability of planets that we have found. It's giving us some idea of how things evolve over time based upon seeing a lot of things at different ages and how they've changed. It's giving us all that stuff, which is basically knowledge. It's not taking humans into space.
No. I mean, like, are we going to be we're getting ideas, and that brings you up to the Artemis too. But we're definitely, the James Webb is giving us like, hints on where we're going next.
We're going to Mars.
Because the big problem there is that where we go next is a lot dependent on us, and we don't have another
technology
life form. And we don't have another intelligent life form to go, look what they did next. Maybe.
But what if you say where we're going next in our study, in our research, and what we're interested in?
I think that's what I mean, yeah.
More metaphorically than physically.
Yeah.
I think what Hubble did was show us pictures of things that we wanted better pictures. What this will do is show us more pictures of things, and we'll still want better pictures.
Because that's how we roll.
That's how we roll.
So goes back to the Artemis. Explain that situation too.
You have to have been alive and thinking about things in 1970 at the time of Apollo to recognize how ambitious we were. Mm-hmm. We did not appreciate that when you go into space, you must take the Earth with you.
Right.
You have to take your environment with you. So we never drew that. We also did not know how adaptable humans are because we never hate humans adapt. Oh, they're terribly adapted. They stop producing calcium when they don't have a gravity field.
Right.
They react to any change in the environment. That's why we are where we are. We've been basically adaptable our whole lives, and we've survived everything that's come our way, and we're here. But that very adaptability means that if the environment changes, so do we. And sometimes we don't have the physics to do it. So going to live on Saturn, we don't have the rockets we thought we would have. Everybody kind of drew this little graph that said we had a covered wagon, we traveled this fast, and then we traveled this fast, and then this fast. Well, we'll go to Saturn in no time. Well, there was a limit to how fast you can move. And that was something we didn't appreciate. So the humans are not, they're way too adaptable to stay humans and survive without taking the whole Earth with them, so that we don't really change their environment except maybe their gravity field. And that we hadn't appreciated. And then we didn't appreciate that we would never go very fast at the rate we're going. We don't have it. This takes a lot of energy to move mass. And we thought we'd have hydrogen fusion under control. We don't. We thought we'd have the energy problem solved. We don't.
Like, we can't even start the vehicle, let alone go.
Oh yeah. Well, we made a faster than light engine in our last planetarium show, and a wonderful time.
We just can't.
And Einstein said, "Hey, that's perfectly fine. If you can channel the energy output of the United States for a whole year at one point in time, hey, you can fire that thing up and go right on."
Theoretically, it works, but yeah.
Can't we just run it down a hill and throw it into gear? I mean,
one hell of a hill. But that's the whole point, is that energy and the ability to control energy and channel energy is not something that we anticipate being so bloody hard. Mm-hmm. So, and I can't remember Apollo 11. Everybody watched Apollo 12, Apollo 13. We worried a lot.
Yeah.
Apollo 14. And then we started having these little rovers running around and people doing so much more stuff. Nobody cared. Mm-hmm. The last 3 Apollo missions were canceled, not because we couldn't do them, but because the public just didn't want it anymore.
We have a short attention span.
Yeah. We're a fickle bunch. And so if we don't, that's why I love this, the Virgin Galactic and all of this stuff. If we don't drag the public along with us, we're not, it's just going to be a photo op.
I was going to say, not even the public, and by extension, business interests. We have to bring that along too. Like, business needs to know, can we make some money off of this, right?
The moon needs to be a tourist destination ultimately.
Or an old folks retirement colony.
That's what I'm hoping for. Yeah.
Well, me too.
Well, if you fall,
I can remember my mother, when she was in her mid-90s. And you know, I'm an only child. So she was saying, we were talking about how much it would cost to orbit the moon.
mm-hmm.
And she said, "Oh, I'd give all my money to do that." I go, "Really?" She said, "Yeah, all of it. That's wonderful." And so I think that there are people who would say, "Hey, those kids don't need it."
Yeah, right. Who need to? Carolyn, you don't get an inheritance.
$1 million on doing this.
That's funny.
So Artemis is going out in March, right?
Artemis has had its stresses, and these are also understandable because there's just so much that can go wrong. It's a new rocket. It's not a Saturn V. It's a rocket that can launch a new spacecraft called Orion. So you got both of them are new, and neither can be tested without the other, and so really tested. And so the March 12th, we hope, launch of Artemis 1 will say, yeah, we can launch this thing. We can orbit the moon with this thing. No people, just the thing. We can make this thing work. And then we got probably 2 years after we prove it can work to really get a human program in which the humans will orbit the moon. Well, that's Artemis 2. And then Artemis 3, they'll land. Now, we picked Artemis because Artemis is Diana, the goddess Diana. Apollo and Diana were brother and sister. Mm-hmm. And also, Artemis is committed to have a female astronaut on board. So we'll get a female.
For those who might not know, Artemis is a NASA project. Who is it? Okay, great.
I think when you look at Bezos and you look at
Elon,
Musk,
Musk, Elon himself. You have to know most of their money is coming from NASA. I mean, they're not doing this except for Musk's satellites that he's launching, his communications.
Or the cars that he puts in orbit.
Yeah, probably NASA paid for more of that car than we HMNS. But he still gets significant amount of money from, and should, by the way. Mm-hmm. If NASA's job is to get people into space and stuff into space, and he can deliver hardware into space, then he should get paid to deliver it. So I'd rather pay him than to pay the French, for instance, with the Ariane rocket. But especially he's in Texas, I mean, at Boca Chica. So at any rate, I think that, where was I? Oh, it's still a NASA. NASA still is what the government.
NASA's the driver.
Yeah, and NASA plus you got the European Space Agency, and you got the Japanese Space Agency, and the Canadians. So
it's a collaborative to some extent.
And sometimes the Russians even get involved.
So, Carolyn, when did you say we're going to start seeing James Webb photos?
By summer.
Okay.
I think so, by summer. We have in our that brings up a good point. We have a show called Unseen Universe. And the beginning of the Unseen Universe show is the James Webb flying overhead, kind of like a picture from Star Wars. It's kind of fun. Cool. And Adam Barnes actually made it. It's very cleverly done. But we do a lot of that show, Unseen Universe, is about the things that James Webb will be looking at. So we're going to try to tweak the show slightly to make it much more now that James Webb is up, the show is really more relevant than ever.
And I'd like to put NASA on notice that I'm really looking forward to my next lithographic set of pictures.
Yeah.
Based on this telescope, I've got the planets, I've got all the Hubble ones. They come in nice sets. I'm ready for a new one, NASA. So I can put it in my notebook.
What's the lifespan of the James Webb? How long is it going to be working for us?
I don't think we know. The nominal lifespan will be years at the most.
Hubble's older than I thought it. I mean, older than we thought it would look. No?
Hubble has lasted a long time.
Yeah, longer than we thought it would.
Yeah. So I think more interesting for me, as far as the planetarium goes, is Artemis, because we're going to open a show called Forward to the Moon that is about Artemis. And we played around with we're working with the planetarium in Boulder, Colorado. And NASA actually funded the show with Lockheed. But the real interesting thing about it is we want people to see the show, to see everything they can know about how Artemis 1 works, how Artemis as a program works. We're building a gateway. We're planning a gateway International Space Station, but it will not orbit the Earth, it'll orbit the moon. So what that looks like, so it has a lot of prep for what this really means as far as moving forward on leaving low Earth orbit. Humans haven't left low Earth orbit.
That's true.
In over 50 years. And, I think that's a bit on time. We need to know what the human body will do off Earth. And we've made up a lot of it in science, and tons of science fiction. But we need to find out what really is possible and what it really means. And that's what Artemis will do. Now, everybody's saying, the next thing for Artemis is to have, it's landing at the South Pole. And that's the best place to land as far as thermal control, day and night control, that kind of thing. But can we make the moon a tourist destination? Can people actually walk on the moon? And if they can't, then this is another photo op. If we can take that leap and get that far along, and you can have a real place people can really be and really, not necessarily really work, but yeah, that's okay too. But really go there. I think that's what's going to make it a place that becomes real. I mean, you think about the moon. Mars has a different origin. Mars has a different story from its beginning. The moon is our 8th continent. It got knocked off by a big impact. Speaking of which, that impact is very unlikely. The asteroid object the size of Mars hit Earth. All of the iron in that object went to the center of the Earth. That gave us the big iron core, which gave us the magnetic field. Thus, we increased our spin. Always good to increase your spin, keeps you from getting too hot on one side. And it created the moon. The moon has stabilized our tilt, stabilized our rotation to an extent, only gradual changes. And the moon's tides may well have been the driver for the change needed for life
to come out. That's amazing.
You have to be a little planet getting a big moon as part of this need to become an intelligent civilization, for intelligence awareness to happen. It becomes a lot less likely.
I've never thought about that as the moon as a continent. That's cool. I think that's a great
stuff. It's the same. The material of the moon is what the continents are made of.
Basalt.
Yep. That's why you see all those dark lava plains, andesite. What basically everything that was friable, everything that was low boiling point as far as rocks go, isn't there.
Right.
Because it was all wiped off that created the moon. But what's left, your titanium and all the things you think about that hang around a lot. And you don't have ores because you do have layers, but they're not like the Earth. You have mostly Earth's surface stuff.
So it's a crust. It's our crust. It's a big ball of crust.
That's my favorite part of the pizza. You can tell we record these around lunchtime.
At lunchtime, I'm hungry too. I was like, pizza.
Well, Carolyn, we're going to have you back when the James Webb starts sending back all of its photos, and we're going to go ooh and ah. We're going to be really excited. So thank you for jumping on with us today, guys. Check out us on all of your favorite podcast apps. Search HMNS Beyond Bones podcast. Spreaker, Audible, Spotify, coming to Apple soon. Every single thing you can imagine. You're going to be hearing my mumbly voice in your earbuds and Kat's better voice, and it's going to be a lot of fun. Dr. Carolyn Sumner, thank you again for joining us, and we look forward to your guidance from here on out.
Thanks, Carolyn.
Okay.
She has a good way of breaking it down and making it real and digestible to average folk like me.
Stop bringing up food and digestion. I'm hungry.
I'm hungry.
I'm hungry.
I'm hungry.
All right,
I'm hungry
bye,
now. Bye.
Bye-bye.